Okay. Oh yeah, I love it. All right, I would. You guys are gonna get to the point where like, if he likes it, that's bad. This kind of problem is so. All right, I'm not gonna say anymore. Let's see. So they give us this. They say find a function, a cubic function, in this form, whose graph has horizontal tangents. What is that another name for us in calculus? Who's the what? Zero? What? Slope with zero. So you can make it more calculus. Derivative is zero. I love it. At those points. Negative 2, 6. And 2, 0? Yeah. There are 4 pieces of information on the board right now. 4. Why do I need 4 pieces of information? Because what am I really trying to find? What will the answer to this question be, fundamentally? No. I know that. I already know that answer.
An expression.
Huh?
An expression.
True, but what parts of this do we not know? A, B, C, D. There are 4 things we don't know, and there are 4 pieces of information. I don't know if anyone's going to be honest. Does anyone not see 4 pieces of information? It's okay if you don't, because I could have went insane. At any moment, I could go insane. Yes? You don't? Okay, I love it. You guys are like, I know you.
No question.
Yes?
What's the 8 plus 1?
Say again, sorry.
The 8 plus.
Oh, it's at.
Oh, never mind.
It's okay. I gave myself an A+ for that. The lowercase a, so you don't want to brag. So here's the 4 pieces of information. There are horizontal tangents at these points. That normally students pick up on pretty quickly. How the hell do I use that? What does that mean? That means, like you said earlier, the derivative equals 0 at those points, correct? So what's the derivative?
3ax squared plus 2gx plus b.
Yes. So if I evaluate that at negative 2, right? It should be 0 there. There's an equation. And I have another one at 2, it should be 0, correct? I'm not going to write them out. I'm not going to do your whole problem for you. The 2 that people miss are these themselves. What is y if I plug a negative 2 in? Well, I would take this and I would plug a negative 2 into it, right? But what do I know the answer is going to be? Freaking 6. Yes? If it goes to the point negative 2, 6, that means when I plug a negative 2 into the equation, I get a 6 out. That's another equation. So like some of you guys did this problem, did matrices. You don't have to, but you can. Right? And it was an exciting adventure. Yes. You don't have to use a matrix on this if you don't want to, but. So then you're going to get another one, y evaluated at 2 equals 0. So this is where it becomes really, some of you guys are just so loose with your notation. I'm desperately trying to get you tighter on that. You can't have g of x. Can anyone tell me what I've done wrong here? What have I done wrong?
You didn't derive it?
Yeah, did I do a derivative?
No.
But I told myself I did. So then I'll feel like I've done the derivative when I haven't. So don't just go, I've done work, that must mean I must have done. No. You haven't done a derivative yet. You're just simplifying the original function. You guys see what I'm saying? It's really freaking important because later you might have x values and it depends. Which one are you going to plug it into? It depends. Do you want to know the slope or do you want to know where the function is? That's what tells you which one to plug it into. Is that cool? Be really clear to yourself. Some of you guys aren't even writing these. You just have stuff floating. I'm like, that is so mean to yourself. Right? I'm supposed to be the one who's mean to you. You're not supposed to be mean to yourself. Be nice to yourself. Telling yourself what the shit you're doing. Yes. Okay. That one's funky. Is anyone still sort of, is that enough for you guys to at least start working on it if you weren't sure what to do with it? No? So just to show you an example, this is the derivative, and if I plug a -2 in, I get 0. That's one relationship between A, B, and C. A, B, and C, right? And if I plug 2 into it, I get 0, not because of this, right? So the derivative, plug a 2 in, you get equals 0. Yeah. Then you have 4 equations. And you shouldn't have to use a matrix, but you can. I love using a matrix. You can kill, remember the whole idea when you have a system of equations is to try to kill some variables. Why do you want to kill variables? There's too many damn variables. So again, math lessons are not life lessons. There's a lot of death and gore and blood in my math when I teach it. I don't want a bunch of little Dexters running around. There you watch it. No Game of Thrones out there, right? Just with the math. Kill the math. Okay. Yes?
The nth derivative of
Oh! So anytime you're trying to find the nth something, that inherently implies there's some kind of pattern happening. So, I can't remember which one it was. Let's see if I can make something up here. Oh, I can do this. Yeah, something easy would be like this. I want to know the nth derivative of this. Well, what's the first derivative? Almost. Very close. You didn't give somebody a term. Either the 2x times. No. It would be ln e, which is 1. What rule is happening? Because is the inside function just x? No, it's 2x. Doesn't it get a term? What's the derivative of the inside function? 2. So let me just put that up. So what happens every time I take a derivative? Another 2 will look like it pops out, yes? But we know it's really just times the derivative of 2x over and over. So now it's 4, right? What's f triple prime? 8. What's f? 4th derivative. So what's f nth derivative? Right, the first derivative there was how many 2's here? Second derivative there was 2 squared. Third derivative there's 2 cubed. Fourth derivative is 2 fourth. So nth derivative there will be 2 to the n. So if I want to know what the 78th derivative is of this for some reason, I would just do 2 to the 78th and then figure out what the hell that is, right? That's, oh God, I'm having so many people. That's what you do. You just do a few for yourself and then see if you can see a pattern. Yeah. Now, some of the patterns will be based on, like, we did talk about n factorial, right? If I remember correctly. So that's just n times n minus 1. All the way down to 1. So like 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. So that might show up somewhere if I remember correctly. That kind of thing. Okay. Love you guys. Anything else before we do a couple things I didn't do yet? I think I think I've skipped over because we didn't have much time to do it. I didn't want to try to ram this into the end of last class. Derivatives of inverse trig functions. You guys excited about that? Oh yeah, I know you are. You're telling me no, but I know you're excited. We can do so much crazy shit now. I know that doesn't make you excited. So let's try the simplest one. Let me ask you a couple questions here. Which variable represents an angle in that expression? No. Yes. What is the normal input for a sine function? For any trig function, the input is an angle. This is the inverse. So the output's the angle now. Yes, that's how inverse stuff works, yes? Okay, I like it. Which means x would be the outputs of the sines. So can anyone tell me what the domain is of this function? Negative 1 to 1. Because that's how far a sine normally can go, and now that is my domain. Because everything's turned. What about the outputs? Oh, that's where things get weird. I don't know if you guys remember this. Real quick little thing about inverse sine. Here's sine. Is that a 1-to-1 function? Is that invertible? Is that a 1-to-1 function?
No.
Hell no, why not?
Fails the horizontal.
Fails horizontal line test. So you might ask yourself, how the shit do we have an inverse function if it's not invertible? Because we had to, if I cut the domain to be from negative pi over 2 to pi over 2, is this piece 1-to-1? Yes. So the input for this is negative 1 to 1. Good Lord, Jeff, what language is it? The domain is negative 1 to 1, and the range is negative pi over 2 to pi over 2.
Are you just writing this thing?
Oh, you saw that? No. Yeah. You know, I'm fluent in Klingon. No, I'm not. That would have been free. So just that's a little review. So I understand if you've forgotten that, but hopefully that makes sense. We have to chop it so we're able to invert it. Okay. Now, how the shit am I going to do this derivative? Do you want to do limit definition of derivative to figure this out? No. Does anyone know how to rewrite this in terms of functions we know derivatives of? I kind of gave it away earlier, right? No, stop. No. No.
Oh wait, no.
What does this notation mean? Does it mean reciprocal?
1 over sine.
No, it means inverse. It's its own function. It's not the reciprocal. So it's not 1 over sine. No. It's the inverse. You guys with me? Okay. So this has to become second nature. In fact, I gave it away earlier. Isn't this, what did we say this was physically? An angle. So can't I, is this bam. That's how inverse stuff works. So what I really did to both sides was I took a sine of both sides. What sine of inverse sine do? They kill each other. So x equals sine y. Bam! Can we do that derivative now? Yes, because we know implicit differentiation. So, all right. Even if you're not excited about, you're like, it's okay if we keep what we're able to do to a minimum, Jeff. That's fine. No, too bad. We're going to expand it. You have to then understand implicit differentiation allows us to rewrite shit to find things we know. Because I don't want to freaking do limit as h goes to 0. Hell no, I don't want to do that shit. I'd rather build it off of something we know already, right? All right, so let's do the derivative of this. I'll do this side. Oh, okay, I did half of it. Man. I love you. You're all like, hey, make it up for that quiz, man. Throw me whatever jokes you want. So that is there with me? That's the derivative. What's the derivative of sine y?
Cosine y times y prime.
Beautiful. Cosine y times y prime. Poor little green. I lost my blue. All right, let's do it. And what do I want to get myself, of course?
Y prime.
Y prime. So what's y prime mean?
1 over cosine y.
Ugh. 1 over cosine. Okay. That's not good enough. What was our original function of? The original
X.
function of x. We should be able to get this in terms of x. really what it is. Okay. Just want to give you a big hug. So there's a lot of review happening right now. And of course, those of us who are a little bit more iffy with a trig, okay. So this might have freaked you out a little bit. Did this sound familiar to anybody? Just a little bit of, okay. Here's something else. And I think this came up on our first day together, if I remember correctly. So this is what we know from the beginning, right? That sets up a triangle. This is the triangle. In fact, if I go ahead and use this, the sine of y is x over 1, right? So which side of the triangle is x?
The opposite.
Sure, I love the SOHCAHTOA. No, I don't, but it's okay. So sine likes y, so this piece is x. And where's the 1? I like it, right? Is that cool? So I really don't have to write this shit. I can just, so this is the angle whose sine is x. And then I can set up a triangle. Why am I doing that? Because I want to know what the shit cosine y is. So what else do I need from the triangle to figure out what cosine of y is? I need the x piece. You guys see what that is going to be? So the hypotenuse is always the biggest, so it's going to be him minus one side squared is the other side squared in the square root. Right? So now what's this? What's the cosine of what?
Root 1 minus x squared.
There you go. So just to summarize, if f of x is sine inverse of x, f prime of x is 1 over the square root of 1 minus x squared. Is that like an obvious thing? Hell no. Inverse trig functions are weird to begin with. So of course the derivatives are going to be extra weird. Yes? No? We don't care anymore? Screw you, Jeff. Okay. So, let's do a quick example with this before we try any more, and I'm already running out of time. So if I wanted to know if f, let's say g of x is the inverse sine of x squared plus 2, and I want to know the derivative. Well, what's the rule for inverse sine? It's whatever's here. It's 1 over square root of 1 minus that square. Right? That's the rule. And of course, what else is going to happen? What's kind of like the main rule that's kind of happening is.
That goes into the x.
All right. So let's take the derivative of inverse sine first. It'll be 1 over the square root of 1 minus this business squared. I'm not done yet. Because what rule is going to be applied here? It doesn't give a shit that it's inverse trig. It doesn't care at all. All it cares about is there's a function inside. So chain rule times, get rid of that. So I really need you guys to realize every time we learn a specific rule for a specific function, that's set. So we use this rule right there. We did. But then chain rule is always there. It doesn't give a shit what the function is. There's something inside of something else. I don't care what freaky stuff's happening here. You better multiply by inhibitor, right?
So this raises the question, what's the bigger asshole, cosine or chain rule?
Well, we'll determine that answer as we go. And of course, what's the derivative of this?
2x.
2x. And then the bottom, you can kind of, I don't care. You could blah, 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 who cares? Okay. So the application of inverse trig derivatives is definitely weird, I understand. What do you wish inverse cosine would be? Given that inverse sine is 1 over the square root of 1 minus x squared, what do you kind of wish inverse cosine's derivative would be?
Like a plus?
Huh?
Like a plus?
This is a plus.
Oh.
So you would hope the inverse cosine would be negative this, which it is. So we could do all the same shit we did here. We would end up with, and this is all on the bottom of the page, 214. derivative inverse cosine is negative this. That kicks so much ass, right? And you can also see that between cosecant and secant. The co is the negative of what the secant is. That's beautiful. So it kind of maintains that earlier symmetry. Okay, we just don't really have the most time in the world because I want to do one other thing before I let you out of here, which was what? Oh yeah, that's right. So bottom of page 214, it's got all those inverse trig derivatives. Okay, and I'm still trying to figure out. All right, I'll think about it. I got one more thing to show you, and then we're going to head out. And just to remind you guys, what's happening Friday? No class. I love you. Some of you guys are like, another quiz? No. So last thing for today. Let me just throw this at you. All right. Look at this function. Just stare at this beautiful function. That's such a beautiful, freaky function. Does everybody see what that is, right? That is x to the square root of x. So is it in this form? That is not a constant. Is it in this form? No, the base is not a constant, is it? It's in both and neither. So I have no rule to apply directly. Stay with me now. If I lost you, come back to me. Here we go. This is really, really trippy. Let me make this y. Does anybody have a problem with that? If you do, too bad. I made it one. I made that one because that's what the hell it is, right? What's the worst thing about this? If that wasn't there, this would obviously be easy as shit, yes. So I really want that to not be up there anymore. What's the only function that can take that down?
Natural log?
Yeah, log. And we like natural log because it's one less letter to write. So I'm going to rewrite that sign. If I take the natural log of both sides, I'm allowed to take that down. I understand some of you guys are now like, that looks so much better. But it does look better. Now it's easier. I have to use implicit, yes? Because this is not a function of x. This is like y and x are both kind of involved. And this is a product, but I mean, relative to impossible, possible is good. Right? So what's the derivative of ln something? What's the derivative of ln? What's the derivative of natural of x?
1 over x.
1 over x. So the derivative of natural log of y, 1 over y times
Y prime.
y prime. Right, good old chain rule. Y is a function of x. Yes, y is a function of x, therefore I have to multiply by its derivative. Yeah, like some of you guys look very annoyed. Oh well. What happens here? So let me rewrite this as x to the 1/2. It's a cool, much better notation in general anyway. So now this is going to be what rule? Product rule. Derivative of x to the 1/2.
1/2 x to the power of negative 1/2.
Leave the natural log alone, plus x to the 1/2 times derivative of ln x.
1 over x.
1 over x. Not pretty, but completely doable. We can clean some shit up. let me do two things. So y prime, I'm going to multiply by y, and I'm going to clean up inside here a little bit. What happens here? X to the 1/2 divided by a whole x. You know.
Negative 1/2?
Negative 1/2, exactly. Half of an x divided by whole x is negative half of x. O half of x. I don't know if I have enough time to point this out. Damn it. What's y? Again, wasn't the original function a function of x? What's bad here is this dude. But what was y? X to the root x. Yeah. me write this as x to the 1/2. Just because, I don't know why. And then you can distribute, not much happens. I don't have time to point this out. Do I? No, you're not gonna get, this is weird as shit. Let me distribute and see if I can't get this send real quick. I don't know, Jeff. Times 1/2 x to the negative 1/2 natural log of x plus x to the negative 1/2. Oh yeah, forgot mine. X to the 1/2 times x to the negative 1/2. That's enough. I'm not going to try. Oh my god. Gross. Kind of gross. But each step was not horrific. And the last step was just brute force, throw this shit in there. I know. It still looks terrible. I know. But now we can handle functions that don't fall into the specific forms. Natural log helps us. All right, that's enough. I've done enough to you today. So that's plenty. Don't come Friday, please. And I'll see you Monday. Come up and let me know if you have any questions. Maria, are you out there?